Cool. We'll see if that works now. I can't promise anything, but the laptop just decided to go sleep, and yeah, something wrong with the virtual machines. I have no idea. I absolutely have no idea. I have to dig into these, but it seems to be smoother now. So after I just shouted for like 10, 15 minutes to my laptop, it's now time to take a look at kind of go back to what I was doing before that. Although I'll just draft like 20 minutes. So let's see. Um, I was at this point where it's like I have the resulting edge, and I want to see if I can, just do a, basically self like factor kind of like so just factor edges, to be honest, right? And I want to take a look at these and see if I can if I can basically yeah, if I can basically take things out of these. That's all I have to check, is I have to check per qubit. Is does it have the same value in all the edges? If yes, out. Um, yeah. So I, it's just probably something like dev factor edges self and then edge IDs. And so the only thing that these needs to do is kind of iterate over all the edges. Um, Edge IDs. Uh, Qubits to be more flexible, right? I think I should give it qubits as well because I have here the qubits. Mm. Oh, and I haven't accounted for the measured qubits. This is something that, but I'll approach that later. So um, factor edges. I do wonder whether I shouldn't keep these as a yeah, kind of simplifying is simplifying, factoring is factoring. So simplifying, what simplifying would do, what simplifying, I'm thinking whether I shouldn't just keep these things as separate functions for the user to apply. Like one might not want to necessarily simplify, factor, right? So when I'm simplifying, I'm trying to understand if I can just basically simplify by using the different bases, right? So that I can go from the z base to the x base, and this allows me to kind of like turn a 0 + 1 into the plus, so kind of simplifying things. But then factoring edges, maybe it's something we should keep aside and kind of say um, it's rather it's rather a function of just the qubits. Like, can I factor the edges where these qubits are in? This means, can I take qubits out of that, or is it part of the simplification? Simplifying would just basically, because simplifying can leave you in a weird state, right? Where you have, as I said, like just one edge, for example. And that's something that you don't want to have. Maybe that would be sort of a steps, verbose, and then like, at the end, that could be an option that's by default enabled factor, and I would just say, if factor, because I don't know, but this we'll see as we play these in a more like real case scenarios. So what this basically would do is for q and qubits, and now I need to check whether all the uh, first of all, I need to check if length of edge IDs is bigger than 1, then we do these, or is equals 1. then we do, it's like a bit of a special case. And if not, because then all I need to do is it's kind of go through all the nodes, take them from the edge, and then multiply the weight somewhere, and that's it. So this is something else here. And then if not, what I'm looking for is I'm looking for qubits that have the same state across all the edges, and these guys go out. Okay, but that's stupid because I shouldn't separate these cases, because if I have just by any whatever reason I have a bunch of edges which are all the same exactly, then this basically the same thing should happen. So actually, yeah, so actually that is. But like I wonder if I had like. Hmm, I wonder with the weights, like in this case, what is it that I want to do? Like, do I have to? But that's really not going to happen, because what the simplify is going to do is it's going to tell me, it's going to say, it's actually going to catch these cases. It's really going to catch the cases where I say, look, um, you know, if two edges are equal, they can merge, and so you merge them, and then the merge will just say, only if they are not different, only if they're different, only if you catch one case where the qubit is different, then it's going to do this thing. But if not, it just updates the weight and deletes the second edge. So, mm, factor. So it's really a special case, because if not, I'm assuming that I could just take things out, right? So I'm just saying, let's do a general case. So for Q and qubits, and then I just go for edge ID in edge IDs. What we do is, take a look at the node. So I wanna. How do I do this? How do I do this? So for Q and qubits. Should probably just enumerate that, and then kind of basically do a bit of a, I don't know a better way to do that. It's just my lack of Python skills here. I would just wanna kind of basically compare. So do I have a no? Do I have a no? What do I have? This helper function. So get qubit node ID in edge. That's what I want to do. And yeah, that is awful from a performance perspective. I know this, but we'll work on a better, improved version of these in the near future. Simplify. Yeah, that was now things are working way smoother than before. Factor than before. This it's just literally the whole thing went just black. My laptop decided to go sleep. Okay, so we've got these. Now we have basically. So we need the qubit, right? And that would be qubits I, and then the edge is basically the edge ID, and then we need. So this is P, this is Q. So for Q we need to get the previous qubit, I minus 1. And now we say, look, are they equal? So can factor, we'll assume true. And now basically say, if self state equal p state and then q state. So if not equal, right? And I do this because I just want to do it once, and I don't know how to break from all this kind of stuff. But yeah, I can actually break probably. So can factor false, and then I can just break from the loop. It's probably bad practice, but whatever. So what I'm doing is I go through all the. So I'm at one edge. I check within this edge. I check all the qubits. No, the other way. I'm in a qubit and I check all the edges for this qubit and the previous qubit. So after I'm done with these, I say, if I can factor, what I want to do is basically basically factor qubit. The thing is, I don't know if these edge IDs is really needed in here. I think I can just go through all the edges of the system, but just in case. So factor qubit, and I give it the edge IDs, right? And then I give it the qubit. So that will basically, the function that will do is it will take the qubit out of these edges and put this back into the system as a non-entangled qubit. Yeah. And my question is, like, do I need to, like, if I have just one edge, right? Let's do a quick test, because I think if we just have one edge, we can ignore the weight. And this means that I'll be done here, right? So I would just have to do and that is just rather, I would say, factor qubits. And this is factor qubit. So this is just one qubit, right? Qubit currently will just be a pass for now, and kind of that's it, right? So if I can factor these, and I go and I kind of life goes on. Factor qubits is not used anywhere else. Oh yeah. Factor qubits. Now let me just do one quick test. So I'm here and I have the system, right? Which looks like these. Hopefully nothing will break now. Yeah, because I actually have to leave. Qubit is not defined. Yeah, because is basically Q. What we're looking for here. So, oh, come on, state equal, it's not read state. Oh, because it's the ID. So, self nodes, and this is for Q. So that's probably what's missing. I want to check whether this makes any difference at all when we actually make a substitution. So I have these, right? I'm saying I have one edge, right? And I have this weight in here. And I'm kind of thinking, I think I can just ignore this. If I replace this by S, what do I have? Let's say that S is basically, you know, both qubits in the zero state. So, and I'm just doing a Hadamard, right? So both qubits are in the zero state. So this means that I just have these. Okay. And that gives me weight 1, of course. Yeah. So I can just ignore that. That's cool. I can ignore that. Because it will end up adding up to 1, probably. Yeah. But symbolically, when I have this, you know, this symbolic stuff, like I don't, in theory, the problem is in theory is that's a weight that one would have to multiply here to generate the state vectors. So I'm feeling a bit uncomfortable dropping that out because when we talk like symbolically, but it should always be the case that this is what happens. Hmm. Yeah, I kind of been hesitant here. But why hasn't it worked out? If I called simplify, oh yeah, simplify factor is true, right? So if factor qubits, did it factor at all? Okay, I'll test that. I'll test that later. Oh God, oh, it was an awful session today. I'm sorry that the whole thing just broke. Probably nobody's watching anyway, but like the whole thing broke and just my mental flow went somewhere else. But okay, that kind of makes sense when I do the substitution. The thing is, if I don't do the substitution, like I still feel uncomfortable dropping these, right? Like, because this essentially means that these are the two things that I need. Like, I need to multiply these by these if I want to really, or it doesn't really matter where I multiply it, but if I really want to get rid of that, these can't just go anywhere else. Although that's, in this case, an obvious constraint that like it tells you this should be and this will be 1, right? And so I could just drop it. Doesn't seem like it's. Oh yeah, okay, that it didn't work because it's just passing. Anyway, maybe tonight I'll do a bit of a follow-up stream. We'll see. We'll see what time will allow for. But it's just anyway. Goodbye. It's getting there. I'm getting there. I'm getting there. I'm getting there. It's gonna it's gonna be a much better tool soon. That will allow us to explore algorithms. I want to use this to explore algorithms. I'm just like symbolically a bit uncomfortable with these. I think. It shouldn't matter because it's 1. It's always going to be 1. Like if that's correct, it's always going to be 1. So it shouldn't really, really matter. So we factor 1 out and 1 out. These things would. I think I'm just going to ignore that. I just should leave a node, which is basically if no edge is left, or if one edge is virtually left, we can assume the weight is 1, and therefore can be ignored. Yeah, because that's the whole like definition, right? Anyway, goodbye.